Recording in progress. Okay, so let me get this thing shared. Okay, so first, you can hear me, you can see me. Do you guys have your workbooks in front of you and your supplies for today and a parent nearby? I just want to make sure that happens so that we can get moving. So workbook, can you hear me? Can you see me? Supplies and parent nearby. So spam the chat with yes if that's good. If not, then I'll give you a few moments to do so. You guys seem like you're pretty ready because I gave you that supply list link in the camp countdown. Okay, so we're ready. Now on to the next thing. So I went through the registration that I don't have a parent home. Okay, Leslie. So you may not, you don't have a parent home. You don't have your parent home. Well, just be safe with the activities. And if anything gets too dangerous, just stop and wait for your parent to get home. I don't think the activity that we are doing today is going to be too crazy. We are extracting DNA from a strawberry with ingredients like rubbing alcohol and soap, which I don't think is too dangerous. But for future times, try to have your parent nearby because we will be using hot glue and stuff during the camp. For safety reasons, we like them to be nearby. But for this, just kind of go with it. If it gets a little dangerous for any reason, just back away and wait for it to happen because you'll have time after the camp to do the challenges and the activities. But I went through the registration and I found out that some of you guys are from far places. I am from Maryland, but I see that there's 6 of you in California. There's someone in Delaware. We've got people from Florida, Illinois, Kentucky. We have a lot of people from Maryland, but that's because I sent out the invitation for my camp to a lot of Maryland camp pages. Oh, Virginia. Yeah, how many people do we have from Virginia? Let's see. Virginia, we've got 3 people. And South Carolina, we've got 1 person. I think you may be the only person from South Carolina. New York. We've got 1 person from New York. But we've got also a person from Washington. We've got 2 people from Puerto Rico. So that's pretty cool. And then on to ages, we've got a lot of 4th graders, a lot of 5th graders and 6th graders, some 7th and some 8th graders. But our biggest number is 4th graders. We've got 15 of you guys. Oh, you're from Louisville. That's cool. Okay, so let me have the workbook shared to the screen so I can show you guys. Oh, you're from Puerto Rico. That's pretty. Oh, Frederick. I'm from Frederick. Okay. Let me get that workbook shared so we can start off this camp. Okay. So this is the first page of your workbook. It's just kind of the welcome page type thing, telling you the times and dates and what the camp is and for who. So, okay, let me introduce you to someone. So we have a chat moderator and a prize patrol person on today. Her name is Caroline, and Caroline is a senior in high school and is in her final year of Girl Scouts. She's also currently working on her gold award, like I'm working on mine right now doing this camp. And she is hoping to inspire middle school girls to explore, well, middle schoolers to explore a future in journalism. And her project is called Youth in Journalism. She hopes to be a doctor, so she's also a STEM girl with a little STEAM thrown in. So we're going to go over this a little bit later, but this is in the beginning of your workbook, so you can go back to it and find it, but we'll be going over this later once we get to the live activity. On to the next slide. So let's pause right here, and all of you guys draw an engineer on this page if you have it in front of you. If you don't, then draw it on a piece of paper near you, but draw this really quick, and I'll give you about a minute to do that. So let's do that. when you're finished with the drawing, type in the chat done so I can make sure that everyone's finished with it before we move on to something else, because we're going to be doing a poll right after this about the drawing. So type in the chat done when you're finished. Okay, I'm checking the chat. I'm seeing a lot of you are done. If you aren't done, raise your hand for a quick second so I can see how many of you aren't done so I can. Okay, so Anne is not done. Okay, there's a few people that aren't done. Okay, you can lower your hands. And oh no, you're fine. It's fine to be late. This is the first day. Emily, it's fine. You don't have to be a good drawer. It's totally fine. Okay, so I'll give you guys like 30 more seconds to finish your drawings and we'll move into a poll about the drawings. Okay, again, raise your hand for a quick second if you are not finished. Okay, 5 more people. Okay, get those finished up while I set up the thing. You can lower your hands again. Thanks. Okay. Are all of us done? Are we finished? Yes, we are. Emily, put the rubbing alcohol. I mean, if it's not cold yet, leave it in the freezer for a few minutes, but then move it to the fridge because if it's, well, rubbing alcohol. Will rubbing alcohol freeze? Hey, Jennifer, will rubbing alcohol freeze if it stays in the freezer, or is it enough alcohol content to not freeze? Because they need it to be cold by the time.
I'm not 100% sure, but my guess would be it would not freeze, especially
well,
within like the next hour or so. I mean, it definitely won't
true.
freeze in an hour.
So how about right now, if any of you have not put your rubbing alcohol in the fridge or freezer, put it in there right now because we need it cold for our experiment. So do that really quick, and I'm going to also launch a poll that I'd like you guys to fill out. Would it just help it be cold? I think has something to do with the reaction that's going to happen, but it just needs to be cold because the instructions said so. So we're gonna stick with that. So put it in the freezer if you haven't already, or put it in the fridge. Just make sure it's cold by the time we do our activity. I'm going to launch this poll really quick. Okay, so start answering that. If you're having issues seeing the poll, then let me know. Where's the poll? Well, the poll should have pulled up on your screen, but if not, then that's okay. Oh, this poll's turning out differently than I expected, but that's okay. That's a good thing. It's a good thing. Where's the poll? Thank you, Chase. Yeah. Okay, so gotcha, Emily. Okay, thank you for your answers. Okay, so I am gonna end the poll really quick and share the results. So here's the results. I was not expecting these results. I was expecting some of you guys, well, at least majority, draw a boy engineer, but that just means that you guys already beat the stereotype. So this camp is to help us beat the stereotype and make sure we know that women can be engineers. And you guys are already at a good start. We've got 24 out of 25 of the people that answered this poll chose to draw a girl. And for the how much do you know about engineering, some of you know a bit, some of you know not much, and some of you know a lot, but that's a good thing. And one of you may know nothing, but that's okay, because we're going to be going over engineering in a quick second. But let me stop sharing that. Okay. On to the next slide. Well, for a quick second, talking about empowering women and how we have already started to beat the stereotype, because most of you drew a girl engineer. Speaking of empowerment, Anais, her mom's a pharmacist and she's a STEM woman, and she wants to encourage Anais to be confident in STEM despite stereotypes. Anais, we're about to bust that stereotype, or further bust it, since it's already sort of been busted. But that's a good thing. That's a good thing. So a little bit about me. So I decided to do my gold award because I want, oh, sorry, one second. Yeah, the poll only had 2 questions. We're going to do another one later. Okay, so about me, I decided to do my gold award, and I decided to choose to empower girls to be future women engineers because I didn't have enough role models to look up to when doing college searching. I'm going into my senior year of high school, so I am looking at colleges, and there's one particular that I'm looking at, the University of Maryland, and I just kind of, I wish that there were more women to look up to and talk to just in general around America. I looked it up, and only 13% of engineers in America are women, so that's a small number, and I was hoping that could spread awareness about that and hopefully beat the stereotype with you guys and any friends you share this camp with. So speaking of me and going to college, I want to be a chemical engineer. So I love engineering. Speaking of chemical engineering, I actually have a shirt on today for chemical engineering. I'm going to have a themed shirt every day because why not? But speaking of chemical engineering, that is the day for today. We are going to be talking about engineering and then moving into chemical engineering with an activity and a few challenges we'll send you off to do. So we're going to share the workbook again. And now we will be on page 7. Let's get that shared really quick. Okay, so here's the about me slide. You can check it out later, but I decided to put my Bitmoji on it because why not? And it looks exactly like me. But throughout the process of doing this camp, I have interviewed over 50 inspiring women who have shared their expertise with me, and now we'll be passing these learnings on to you, and you will get to meet several of these role models throughout this week, and you'll meet a bunch of them on Friday during our Q&A session, which will be during like the live camp. But you can, if you want to learn a little bit more and read the entire page, you can check it out later. But on to the next page. Intro to Engineering Day 1. This isn't actually a page in your workbook. The green pages mean that we wanted to show it to you, but it's not actually in your workbook. And if you ever see a page that is outlined in yellow, that's a review page. It's for review so that we remember. On to the next page. So this is a fill in the blank, so pull out your pencils and we will go over this page right now. So let me see if I'm able to do this. We have a drawing pad, so we're going to see if we can write in the words as we go. Yeah, here it is. So engineering. is creating structures, machines, systems, and processes using blank, blank, and blank. So in creating structures, machines, and systems, they use math, science, and technology. STEM, those are the other 3 letters in STEM. So math, science, technology, and engineering. So fill that in. And then engineers do the engineering. They are creative problem solvers and inventors. They figure out how and why things work and build solutions to make things work better or differently. Engineering is all about problem solving and creating solutions. So within engineering, there are 4 main engineerings, and we go through 3 of them in depth and the 4th one on Friday. We are going to be, so the 4 main branches: civil, mechanical, chemical, and electrical. You may think, well, are those the only 4 engineerings? Well, there are 4 main ones that a bunch of other ones branch off of. Quick question, have all of you filled out this page so I can move on to the next one? No, okay, well, if you have not finished it, then click to the next page. Here's the filled in version, so you can fill that out really quick. This question and Q&A, I'll answer that really quick. Okay, Stella, you do not have it printed. That's okay. We will be posting this filled in page, this page right here on the screen. We will be putting that on the Facebook group. So after this camp, we'll be posting it. You can print it out and you can fill it out then, or you can just, I guess, print out the answered one, whichever way you want to do it, but it will be on the Facebook group. Okay, so all of you are done or have known how to do it later on. Let's move on to the next page. So of the core 4, here's a bunch of examples. We have highlighted the ones we will be going over, including in the top right corner: aeronautical and aerospace engineering. They actually branch off of mechanical because they're building like intricate structures, but they also need a knowledge on specifically aerospace and aeronautical because they have to deal with different materials if they need to make things lighter, or if they need to, like, they just need to focus on certain materials and stuff that focus on aerospace and aeronautical, but we'll go into that later another day. So those are examples of ones that branch off of the core 4. Yeah, if you don't have the page printed either, you can just go along with us, print it out later, or don't print it out at all. You can just go over it with us and print it out later, or just go over it throughout the week. But after that, on the next page, I will be showing you the engineering process. Next page. Here's the engineering process. So there's a bunch of different kinds. There's one that's a full circle, and there's this one that's like 2 steps and then the circle. I chose this one because to focus on this week because we're identifying the problem, then exploring different ideas, and then we're moving into the designing, creating, trying it out, improve, trial and error circle of trial and error, trial and error, trial and error. You'll design, like someone will design something, then they'll create it, try it out. If it needs improvements, they'll design it, create it, and try it out again, trial and error. So just remember throughout the week, if you don't get something on your first try, that's okay. It's normal to not get on your first try or your second, third, or fourth, but just know that if you don't get on your first time, you have a chance to make it better. So don't worry if you don't get on your first try. So next slide, we have a cute little crossword puzzle that you can either do after camp or if there's any moment that we may go over it. But this is just here for you to remember the keywords, but just know that the words on the crossword puzzle are in that little picture thing. They're the words in red. And we put a dash in there because we had to like make the two words into one. So there's a dash and we put that in there for you. So there's no misunderstanding or confusion. Next slide. So let's discuss. So what did you hear about engineering so far? You can either type it in the chat if you don't have it, or write it down first, then type your answer that you chose in the chat. But this is so that you can go back to look at it if you forgot, what did I learn about engineering? Then you can go back to this page and look at it. Or if you're like, just any part, this is just kind of a review page and a page for you to further remember engineering. So either fill it out and then put it in the chat, or if you don't have it printed out, you can put it in the chat right away. Yes, that is very true, Ruby. That is true too. The engineers make things using math, science, and technology. We're trying to break gender stereotypes. Yes, that is the main goal of this camp. So we can know that women can be engineers too. Yes, engineers are people that design and help make things using STEM. Oh, that's cool. Your mom's an engineer. Nice. Your cat wants to be an engineer too. Definitely very interested in this camp. If I had a cat, they would be too. So it's kind of funny because STEM, science, technology, engineering, and math. Engineering is in STEM as a letter, but it also uses STEM. So it's like this big cycle of STEM and engineering. So if you ever hear STEM, it also relates to engineering, or if you hear engineering, it's STEM. So it's just kind of like this weird cycle that I still don't understand how it fits into it while it also uses it, but it is it. Yeah. Engineers design things to help solve problems. That is true. Okay, so raise your hand if you haven't filled it out yet. That you have to do trial and error with science, technology, engineering, and math. Yes. Use math and science and technology. Yes. Okay, so raise your hand if you haven't filled it out yet, or that engineering is the combination of math, science, and chemical and engineering itself. Well, engineering is a combination of math, science, engineering, technology. Engineering is STEM, and then chemical branches off from engineering. Okay, so Mara, G, you don't. That's okay if you don't have it. You can either fill it out later or just put your answer in the chat. Engineering is the use of scientific principles to design other things. Yeah, that's a really good explanation. Yeah, it's okay. I'll give you about 30 more seconds to finish it, and then we'll move on to the next thing. By the way, Kate and Mara, you are only in the chat. You are only sending it to host and panelists. If you want everyone to see it, then click the drop down and click everyone. Okay. Are you finished yet, Mara? So I can move on to the next thing. Okay. So click to the next one. If any of you did not have a good answer or did not print out the workbook, this green page will be posted on the Facebook group. But a few examples of what you hear about so far with engineering. Engineering uses STEM. Engineers are problem solvers and inventors. Engineers find solutions and problems. And the four core engineerings are civil, chemical, mechanical, and electrical. Okay. So next slide. Today is chemical engineering. And then throughout the week, we'll also go over mechanical, aerospace, aeronautical, civil, electrical, and more. So stop sharing for a second. So I'm going to do another poll. So now we've gone over engineering. Now, how much do you know about engineering? And also, since we're about to go into chemical engineering, how much do you know about chemical engineering before we go over it? So answer those really quickly. So by the way, Lillian G, she might be interested in engineering, but she has a cousin in civil engineering and a computational engineer and another cousin in computational engineering. I think Lily will enjoy this camp and she'll get to explore several types of engineering this week, including the ones her cousin is in and more. So I think, so there's 27 out of 31 people. So there's 4 more. Okay, so you chose a little bit. Okay, so I'm going to end the poll and here's the results. So I would say that we have upgraded or improved our knowledge of engineering, and some of us could know a bit more about chemical engineering. So let's move on to that. So share the next thing. Technical difficulties. Give us a few more seconds. Yay, more words to guess. I like it. Yes, more words to guess. We're about to get to that, but we are having issues sharing the screen. So we're fixing that really quickly. Okay, we got it fixing, working. So chemical engineering, still day one, but another topic within it. So, oops. Okay, so the next slide. So chemical engineers solve problems using their knowledge of chemistry and chemical reactions to develop solutions. So they have a specialized knowledge of chemistry and chemical reactions. They design chemical manufacturing using chemical reactions and processes. So we'll fill that in really quick. So they design chemical manufacturing using chemical reactions and processes. And they refine raw materials and mix compound, and process chemicals to make new products. So chemical engineers experiment with the controls and variables for the optimization of the outcome. But everything is made of chemicals. And if you know how to change and combine chemicals, you can make all sorts of new materials for manufacturing, pharmaceuticals, fuels, food, healthcare, paper, polymers, and many other products. So here's the filled in page with the words. So again, this will be on the, what does optimization mean? So how about, here, click to the next slide. Let me introduce you to someone who could explain that in more depth. So Jennifer Lawrence Jones is a chemical engineer that we have on today. She's also a Girl Scout leader and was a Girl Scout herself and also earned her Gold Award. She completed her degree in chemical engineering at Florida Institute of Technology. She also has a master's degree in engineering management from the University of South Florida, and she has worked at a variety of interesting places in her career, like RP Shearer, Coca-Cola, and Tampa Bay Water. So she can maybe go in more depth about the page before this one and let you know a little more about each of the words that we have gone over today. Yeah, we'll go back to that right now. So Jennifer, would you like to expand upon this page?
Hello, everyone. Yes, so the question was about optimization. So optimization is trying to make something happen the quickest it can, the most cost effective it can, like just make it the best it can be. So it's all about everything with the chemical process and the manufacturing process, whatever's going on to make it fast, quick, and cost effective. Does that explain that? Do you want anything else on that page? Any other questions about that?
And let's go over the other words too, like manufacturing, processes,
Okay.
raw materials.
All right, so manufacturing is taking some kind of raw material and turning it into a finished product. It's the whole process that happens throughout that transformation. So there's many different manufacturing. You manufacture cars, you manufacture chemicals, we manufacture like even furniture you guys sit on, like everything that's a process that turns some kind of raw material into a final product is manufacturing. And a reaction is something where one chemical is turned into another chemical. So there's different reactions that can happen throughout the manufacturing process to transform, like I said, one raw material or one chemical into another raw material or chemical so that it can continue on in the process. And a process is kind of that whole transformation that happens. So they're all different processes that happen within the manufacturing. It's kind of all interrelated. So a raw material is something that is in its original form. So like wood would be a raw material, or a base chemical or a base metal would be a raw material that's the beginning of the process without it being turned into something we can use at the end. Chemicals are some type of, how to find chemicals. Let's see, someone said a manufacturing is like an assembly line. It is a lot of times like an assembly line. Sometimes it'll go in one line, but sometimes it'll have like different areas that it breaks off and then comes back into the main line. Let's see, a chemical is a different type of element. It could be a liquid, it could be a solid. It's something that's used in a process. And then products are things that we use every day. So like I mentioned before, cars, cleaning materials, beds, furniture, the plastics that we put all of our food in, like all of those things are products. All right, any more questions on that page?
I think you've answered all of them. So how about we move on to your presentation that you've had made for us?
Okay. All right, let me share my screen. Okay, so this is about chemical engineering. And I'm Jennifer Lawrence Jones. So what can a chemical engineer do? Chemical engineers work in places like petroleum plants, which would make gasoline and diesel to make our cars go. They work in chemical plants, so making things like bleach and cleaning chemicals that we use in our house, like the Windex and the Lysols and all of those things. They would also work in recycling plants. So we recycle a lot of different materials. We can recycle glass, plastics, paper, aluminum, and all kinds of metals. They can work in utilities, water, wastewater, electricity, and gas. They make paper. So there's a lot of different types of paper we use. The writing paper that we write on, toilet paper, paper towels. They also can work in pharmaceuticals. So there's many different type of pharmaceuticals they can make, capsules, soft gels, and tablets. There's food and beverage manufacturing plants. So pretty much everything that you guys buy in the grocery store, like soup, crackers, meats, juice, sodas, everything that's in some type of package, your spaghetti, everything is made in some type of food or beverage manufacturing plant. There's also materials production. So all of those raw materials that we're going to use in making other things, there has to be plants that make those too. So there's plants that'll make the plastics, the metals, cloth, etc., that's then sent to another plant, like one of the ones above, to turn into a final product you can use. And there's also biomedicine plants where they're making different kind of vaccines and cancer medicines, things that are injectable type medicines that treat specific things, kind of like the COVID vaccine that everyone's working on now. That's probably a lot of chemical engineers and biomedicine people working in that field, working on those type of vaccines. And then all of these different processes require specific and specialized equipment. So chemical engineers also get involved in the design and production of building those machines that can make all of those different manufacturing. So there is a huge variety of what chemical engineers can get involved in. And Ruby, just so you know, I can't see the chat when I'm in the presentation thing. So if there's any questions, you guys will have to break in and let me know there's a question.
Yeah, so far there's nothing, but I'll let you know if there's any.
Okay. All right, so a little bit about me. When I was in high school, I took a lot of math and science honors classes and college courses throughout high school. And I was also in Girl Scouts, like Ruby told you. I earned my Gold Award. I also organized and led a summer camp for my Gold Award. And I was also in Honor Society. And then in college, I was Chemical Engineering Student of the Year in my junior and senior years. I also got involved in the Society of Women Engineers while I was there. And the last year I was in school, I was the president of Society of Women Engineers, which is also called SWE. And I organized and led Engineering Week. So I planned all of the activities for all of the engineers at the college, well, engineering students at the college, to learn about different type of engineering. And then while I was at college, I also got involved in different organizations and societies there. So Tau Beta Pi was an engineering honor society. AICHE is American Institute of Chemical Engineers, and ACS is the American Chemical Society. So I got involved in all of that kind of stuff throughout getting ready to be a chemical engineer. So I have a bachelor's in chemical engineering from Florida Institute of Technology and a master's in engineering management and also total quality management from University of South Florida. And then other job-specific training that I've taken throughout my career is I'm got a couple certifications in reliability, certified reliability leader and a certified maintenance and reliability professional. And reliability is making sure that whatever process you're doing will happen consistently every time you turn it on. The machine is there, it's functioning, it's available, it's reliable, you can depend on it. That's what reliability means. So these certifications that I've gone into continued studies once I got my degrees I've learned a lot more about the manufacturing process and how to make sure that it's stable and reliable and will work when we try and turn it on and make whatever product we're making. Other things, Microsoft Word, Excel, PowerPoint. So I do a lot of information, documentation, presentations in these type of programs. I also work with Maximo. It's a software that creates the maintenance work orders for the mechanics to go out and fix equipment. And I have a certification in that. Also CPR first aid. We like to have everyone at our organization, every organization I've worked at, certified in CPR and first aid so that in case anybody has any issues, people can help out. Then I've also been trained as a hazmat responder. That means if we have some type of chemical emergency, chemical spill, I can go in and help respond to that spill. And an emergency incident commander. So in my current role, I work at a utility company. And if we have an incident, I'm in Florida, so sometimes we have hurricanes. And if we were to have some kind of emergency incident around hurricanes or cyber attacks or any type of things, I can step up and be an emergency incident commander. So those are different types of specialized training I've had throughout my career. So my first job out of college, I was a laboratory manager. And I worked for about 2.5 years at a very small contract manufacturing firm, Valgene and also CCI. I did R&D formulations and QA/QC lab work for different types of personal care products. We made different suntan lotions like Panama Jack there. We made lip balms for Hawaiian Tropic. And then we made various lotions, shampoos, conditioners for a bunch of different companies. And they also had a small line in the back that made hummingbird food, where sugars and different things that go into hummingbird food and package that. It was a pretty interesting place to work. And I learned a lot of things about how they combine chemicals to make all of these different products that we use every day in the bathrooms when we go to do our personal care stuff. My next job, I worked at RP Share, which also while I worked there, it changed to the name of Cardinal Health. They were purchased. I started out in R&D formulations, and then I moved into project and process engineering, and then eventually into maintenance supervision. So a contract manufacturer is one that makes products for another company. They don't put their own name on it. They always make the product and then give it to another company and they sell it and put it on the shelf. When I worked there, they had 3 different manufacturing plants. One of them made the pharmaceuticals and over-the-counter medications. Another one made paintballs, and another one made bath oil beads. So it was a pretty interesting place to work. One of the products that I worked on while I was there is the Advil liquid gels. So that product, I did some of the final R&D formulations in that before it went to market. And I was involved in all of the final development work on the production floor, getting all the testing done so that it could be sold in the stores. And that was pretty cool to work at. This machine right here that you see is a soft gel production machine. And inside here, these little tubes at the top are filling the liquid into the soft gel. And then there's sheets of gelatin, which you can't really see in this picture, but you can see better in the next picture, that come through here. And it gets cut by these little dies into the shape that it needs to be. And then it goes down here. This is a drying machine in the back. So here on the next one, I went into a little bit more about the different kind of production equipment that we used there. So this first here is a tank that we would mix all of the liquids in. So the liquid that went in the middle of the soft gel, whatever it was, would get mixed in a tank. Then that tank would get rolled over to a soft gel machine. Here you can see a better picture of where the gelatin is on the back of this one. And then it's being formed on this big roller that goes around through the machine. And then the soft gels come out here on the roller tray or roller conveyor. Then the soft gels have to dry because they're very, very wet when they come off the machine. They're like pliable, almost like Jello. And you have to put them on these drying trays over here. And then they sit in the drying trays, and they put these drying trays in big tunnels that blow air across them. And then that air is very, very dry air, and it helps dry them out. Once they're dry, they can go through machines that sort them. We can print them in machines like this. We can make sure they're the same size, do quality checks. There's a lot of different machines that they'll run the soft gels through. And then finally, they're packaged into boxes and then sent off to whoever we're making them for the final packaging into the things you buy at the store. So like I said, this was a contract manufacturer. So they didn't do any of the final packaging there. They just did bulk packaging and then sent them out to whoever was purchasing from us. Are there any questions yet, Ruby?
Yes, we've got two. What did you do when you worked there? I think it's being answered throughout the presentation. And then someone
Okay.
else, Mara, said, I wish I could do or invent something.
Okay, yeah, cool. Yeah, there's always lots of things. As a project process engineer, you could get involved with inventing things on the production floor to make the process move more quickly or easier through the process. After I worked there, I worked at Coca-Cola at one of their juice manufacturing facilities, and I worked as both a maintenance supervisor and a production supervisor on the production floor. In their juice plant, they make all these different products that I have flying under the screen here. The Simply Juice was their main product, but they also made Minute Maid products, vitamin waters, Fuse teas, Gold Peak teas, Powerades, a lot of different stuff there. And then the other thing they did is they worked for McDonald's and they made the smoothie concentrate that they send out to each of the McDonald's to make their smoothies in the stores. So we would take raw materials of strawberries, blueberries, blackberries, mangoes, big, huge drums of this stuff and pour it into the mixing equipment. Go to the next slide. So here's some of the mixing equipment. There would be big tanks like this again. We would pour all these big drums of stuff into and mix it up. If we were making juice, here's a filling machine that would fill the juice. Those juice bottles would then roll down through the conveyor belts until they went to the final packaging. And then the smoothie concentrate would get put in Mylar bags like this. And then we had these robots at the end of all the production machines that would pick up all the boxes and stack them into pallets so we could ship them out. So it was a pretty cool place to work. It's very, very fast paced, very high speed manufacturing. Like I said, I was involved in maintenance and production supervision. So anytime a machine went down, it was a huge deal to get it back up and running. And that's where I started learning a lot about reliability and trying to make sure that the equipment would run every time that we turned the button on. So there's a lot of things within reliability and doing the preventative maintenance, making sure you're taking care of all the little components of the machines before they break, checking them out, and then just making sure you run it at the right parameters. There's certain speeds, there's certain temperatures, certain pressures, and things that you run at to make sure that your process is reliable. And I currently work at Tampa Bay Water. And when I first started here, I was a technical specialist, and now I'm the maintenance planning and reliability manager. I work on all kinds of different equipment, trying to make sure that they're reliable. I do equipment evaluations every year and determine if equipment is coming to the end of its lifespan. I also am in charge of that computer system, Maximo, I mentioned at the beginning of my presentation, that provides all the work orders for the mechanics to go out and fix equipment, to check it out on a routine basis, to make sure something is not going to break. And then here's a few pictures of our plant. This is one of the buildings that I work in. And then this here is showing a gate system across a canal, and we pull water off this gate system to treat it. I didn't say, Tampa Bay Water is a utility water supplier. So we're supplying water to cities and counties that then supply it into your guys' homes. So this is like when you turn on your faucet in the bathroom, water would be coming from us. This is a lady in our laboratory who's testing some of the water. And then here's like a sky view picture of one of our manufacturing plants where you can see tanks that are full of water. I mean, these are big, huge tanks. And then different chemical treatment processes happen in through here to make sure that the water is cleaned and safe for people to drink by the time it's sent out of our plant. And then this over here in the corner, I live in Florida in the Tampa Bay region, and Tampa Bay is saltwater. And so this is a desalination plant. It's taking the salt water, running it through RO membranes, and then pulling out all of the salts and things that are in the salt water to make just pure water on the other side. And then we also take that water and supply it to people. We had the biggest desalination plant up until about 2 years ago in the United States. And now they built a bigger one over in California. But we have a very, very big desalination plant on Tampa Bay. Here's a few other pictures of water treatment equipment. So this is a well. So we do dig wells that go down deep 100, 200, 300, 400 feet, depending on how far down the water table is or the aquifer. And we pull water up through these wells. And then this down here is a set of pumps. So when you're moving water from one place to another, you have to have these big pumps that helps move the water. And then over here is a chemical treatment skid. So each of these tanks would have chemicals in it, and they pump it in through all this valving systems here into the water to make sure it's treated. So you guys probably know that water gets chlorinated to make sure that no bad stuff grows in it. Because if you don't chlorinate it, like bacteria will start growing in it and stuff. And you want to make sure that it's treated prior to sending it out to people's houses to make sure that it stays safe to drink. So my current responsibilities, like I said, I work on equipment and I go out and analyze it every year, perform evaluations, work with different subject matter experts if it's something I'm not specifically familiar with. And I run a program called RPM, which determines what type of capital investments we need. So capital investments are, let's say that chemical treatment skid keeps having leaks on it and the pumps are no longer pumping effectively. Well, it may be time to just replace that entire chemical treatment skid and get a whole brand new one. So I would give that kind of information into the engineering department and say, hey, you guys need to plan on doing this replacement in the next 5 years. Or here's a pump, it's starting to deteriorate a little bit, but I think it'll last 10 more years. And so I give them recommendations as to when we need to refurbish or replace that equipment. The other thing is the Maximo system. It is a CMMS, which is a computerized maintenance management system. And it, like I said, takes all of the work orders, sends them out to the mechanics. Currently, we're printing work orders out on paper. I'm in the process of implementing a mobile solution, and the end of this month, we're doing training on that mobile solution so that all of the mechanics are going to get iPads and Android tablets, and they'll be able to do their work orders right on the tablet. I'm really pretty excited about that we can stop printing out paper and wasting all the trees. I also work with the IT department or information technology department whenever there's time to upgrade the Maximo software, or if we need a new functionality, we need it to do something it doesn't already do. I help design that and make sure that those software changes and upgrades get put in place. And one of the last things I do, which is really a lot more of the chemically part of my job, is I'm in charge of the cathodic protection program. So what that means is it's basically preventing rust from forming in our water pipes and keeping leaks from happening. So we have these cathodic test stations throughout our pipes, and we do annual inspections on them. And then I'm also in charge of the contractor that does the repairs. And I'm sure you guys have never heard the word cathodic test station before. So I wanted to show you a little picture. So we have pipelines under the ground, and we would have little wires that run through that and then come to a conduit up to the top, which is our test station. Also in the ground, we put an anode. And what'll happen is the anode will degrade faster than the pipe as long as you keep a certain electrical potential on it. And you measure those electrical potentials with these terminals. This is like a blow up of the inside of this test station. So there's electrical, these wires go down and you can measure the potentials. And here are some pictures of the actual ones out in the field. So here shows a pipe in the ground, and here's one of those anodes. And here's where the wires are coming up to go up to the test station. And then here's where the test stations are. And there's a guy with a electrical meter, and he's actually testing the millivolt potential across these wires. And then we also put these little things in the ground that say, hey, there's a cathodic test station here, be aware of it. So that's a pretty cool chemical portion of my job, that I'm in charge of the guys to make sure that our pipes do not degrade and do not get holes in them by having this cathodic process happening on our pipes. Do we have any more questions, Ruby?
There aren't any questions, but people are sharing in the chat. Wow, you're amazing. I know, right? She's so impressive and successful. She is amazing.
Okay, cool.
I totally agree.
All right. So I just wanted to review for you guys a few of the chemical engineering terms. Reactions are when chemicals mix together and change each other. Catalysts is something you can put into a reaction to make it speed up and go faster. Optimization, making a process the best it can be. A process is a series of actions to make something happen. Whoops, I want to do that. Raw materials are materials before they go through processing, some type of manufacturing process to turn it into a final form that's useful for us. Manufacturing is a process to make goods or services. The chemicals, a substance produced by or used in a chemical process, and production, the act of producing or manufacturing items. And if you are interested in becoming an engineer, what should you do? Make sure you take math and science courses in school, take honors, AP, or college level if available, study hard and get good grades, go to engineering summer camps like you guys are all doing, get involved in engineering societies, and if there's any engineering clubs or things that they have at your schools. You could also learn about engineering drawings, which are CAD programs. Learn about controls and programming. So all of these manufacturing processes, they have to be controlled. I didn't really talk about that, but there's all kinds of controls, things that measure temperatures. They watch for sensors of movement and the programming that goes behind doing things when certain things happen. That's a huge part of it. Learn about different things like Microsoft Office programs, Word, Excel, PowerPoint, all those type of things, and then go to college and study engineering. And I want you guys to all have a great day. And that's pretty much the end of my presentation.
Thank you for presenting. It was very interesting. I enjoyed every time you presented it, even throughout the tech rehearsals. Okay, so let's represent.
Is there any more questions before I finish?
Oh, everyone's saying thank you in the chat. Oh, I like the seashell smile at the end. Really amazing. Thank you. You're so cool. Thank you with a smiley face.
Awesome. Okay, well, I'll be on. If you guys have any further questions, I'll be on for the rest of today. And I'm just going to go back on hide.
Okay, so let me re-pull up the. Oh, someone has their hand raised. Oh, not anymore. They put it down. Now you're good. Okay, so let me pull up the slideshow really quick. Oh, my camera's off. I'm back. Oh, yeah, thank you. Okay, let me get this slideshow opened. Okay, so for chemical engineering, we have another crossword puzzle for you with all the keywords we just went over within the fill in the blank page. So again, the red words are your little word bank that you can fill in. And then for one of the words that was 2 words, we had to put a dash between it so that we could keep it as 1 word. But yeah, when you're finished or having issues with your crossword puzzle, on the bottom right corner, there's an answer key. So you can click that. So on to the next page. So again, let's discuss. So what does a chemical engineer do? You can say anything you feel like. What can a chemical engineer create? And what special things do they know about? Also, if you want to, or well, we all should, what's your favorite thing that you heard from Jennifer's presentation? My favorite thing was that she worked for Coca-Cola. I thought that was pretty cool. But yeah, fill in your answers and what's your favorite thing about Jennifer's presentation? You can't post it? What do you mean by that? Also, for your chat, Mara and Patricia, you are only sending chats to the hosts and panelists. So if you could, you can change that to everyone. Yeah, they build things from raw materials. I thought it was cool that she worked at a water plant. I thought that was pretty cool too. Her job at Tampa Bay, yeah. It does not show. Well, I'll just read out your comments out loud so everyone else can see it. Yeah, you can print it later. But if you want, you can share your answers in the chat so we can all see them. So you can create stuff that can help the environment. Yeah, that's true. She makes things for other companies. Yeah, like how she created the concentrates for McDonald's. Chemical engineers experiment and retry to create things to help and solve problems. Companies. Oh, yeah, yeah. And all the machines, yeah. They're so intricate and big. I could not understand how they work. It's crazy. Chemical engineers have a lot of choices of work. They combine, make things from raw materials. I love how she has a lot of experience with different things. Same. It's cool that she has many different jobs over time. I like all the jobs that she's done. I'm trying to look for a career in something like that for chemical engineering for me. They make sure your pipes don't rust. Yes. If the pipes rust, then the machines don't work. So that's a very important role. By the way, they can create furniture, paper, Legos, etc. Yes, that is very true. By the way, so since we went over engineering and chemical engineering, it may run a little bit late today, maybe like 12:15 or so, because we don't want to rush the experiment that we are going to be doing very soon. So we may stay on a little extra few minutes if you don't mind, but yeah, we don't want to rush anything. It was very impressive how many jobs she has slash had and how many things she has done. Yeah, it's very impressive. Very quickly, raise your hand if you have not finished filling it in. Now you're good, Emily. Okay, so we have a few more people finishing up. That's okay. Yes, very impressive responsibilities. You can't find the page. The page is page 19 in the workbook. If you're ever confused on what page you're on, just look in the bottom left corner of what we are presenting. Yeah, like the mouse she's showing. We're on page 19. So I'm going to move over into the next page to show you guys what answers there could have been if you had trouble or you don't have it in front of you. So what does a chemical engineer do? Well, they solve problems using their knowledge of chemistry and chemical reactions to develop solutions. They design ways to turn raw materials into valuable products. And what can a chemical engineer create? Well, they make new materials for manufacturing pharmaceuticals, fuels, food, healthcare, paper, etc. And what special things do they do? Do they know about chemistry, chemicals, and reactions? So this, again, will be posted in the guides. I'll give you a few more seconds to finish off these pages or put your comments about her presentation or chemical engineering in general in the chat. But if you aren't on the Facebook group and you want to see this, you can take a picture really quickly of the screen or like with a phone. Okay, so raise your hand if you need a few more seconds before we move on. Okay, so I'll give it about 30, 45 more seconds and move on to the next thing so we don't run too late for today. But the other days we're only going over one topic, so hopefully we don't run late any other of the days. Okay, so let's move on to the next thing. So recap, this time I'm actually gonna go over it. One sec. Okay, so activities versus challenges. So I thought it was cool that chemical engineers can do many different things. Yes, they can. It's just a wide range. So back to activities versus challenges. An activity is they're all activities, but the activity is the one we will be doing during camp. We're going to be doing one during camp each day. One of the days I think we're doing two, but that's because they're two smaller ones. We're doing one activity during camp, and there's a few challenges that you can do all of them or pick from for the on your own challenges after camp. So activities will be guided during camp and explored further on your own. So you will be doing it live, but the improvements will happen as a challenge after camp. So like say we were building a bridge, we will build it during the camp, but we will do the improvements to it after the camp. But that was just an example. That's not what's happening today. And then the challenges will be introduced. We will give you an explanation of it during camp, but again, you'll be doing it after camp and posting it on the Facebook group if you're on the Facebook group. So here are the warning symbols. So every one of them will have parent supervision required. So yeah, parent supervision, because sometimes we'll be using hot glue guns or just anything other dangerous-ish. So we like parent supervision. Safety glasses will be on certain experiments, which will either be like launching stuff or an explosion type thing, not an explosion, but like a reaction. And then if it's messy or you need to go outside for it, there's either a door icon or the little messy splat icon for recommended to go outside because it's a messy activity. And every time you see a hot glue gun symbol next to an ice water symbol, you'll know that there will be hot glue in your activity. So you should have a bowl of ice water nearby in case you burn yourself to minimize the burn. So you can keep it to a 1 degree instead of like a 2 or 3 degree, which means bad. So we want it to be the least harming if you ever do end up burning yourself. And that's why we have parent supervision, so they can help you out if anything bad goes wrong. So yeah, next page. So I'm going to introduce you to Chase. Chase is a senior in high school. She's in my grade, and she's also in her final year of Girl Scouts. She has been a Girl Scout for 13 years, since kindergarten, and she enjoys horticultural and agricultural biology, and she also enjoys hiking. She plans on getting a major in psychology, but she's also a STEM girl. Yeah, wow to that. Okay, so we are running a little late on time, so I'm not going to show you the video, but let's go right into explaining and doing the activity. So here's Chase. Everybody get your materials in front of you if you don't already, and she'll explain the materials that you need during. Chase, would you like me to screen share the instructions, or, well, yeah, because some people don't have them, so I'll screen share it really quick so they can have the supplies in front of them while
Yeah,
you
you can
explain.
screen share it, and then if somebody just doesn't want to look at the screen share and wants to see my video, then they just need to pin my video.
Yeah,
Unless
so
that's not how a webinar works. I'm not sure how a webinar works.
let's try it out really quick. So let's share it and see if they can pin you. If not, then I'll do something. So here is the, click forward one more. Okay, so here's the page. Guys, let me know if in the chat if you're able to pin her still to be your full screen, or if you are unable to do that. Like you don't have to pin her, but if the option is available, then put it in the chat because I'd like to see that. You can't. No, you can't pin her. Okay, so let me see. So no, you can't. Okay, so there are some girls who don't know the activity. Here, I'll leave it up while you're explaining the supplies so that they can get it in front of them. And then after that, I'll leave you as being pinned. How about that?
Okay. Somebody said they can see half of the screen as me, so that sounds fine.
Okay. So yeah, I was trying to make that happen, but yeah, so explain the supplies, and then I will take away the screen share, and then it'll be just you so you can show them a step by step.
Okay, do you want me to tell the first part or the supplies first?
You can tell them like the identify the problem and stuff, and then the supplies. And when you get to prep, I'll turn off the screen share.
Alrighty. All right, so this is the fruit DNA extraction. We're going to be doing strawberry DNA extraction today. So we have already identified the problem, which is that we want to extract the DNA of a strawberry using the chemical reaction and process of extraction. This can be used in pretty much any organic matter, and a lot of chemical engineers use it in their day-to-day life. Except instead of doing the process by hand like this, they have a little kit that does this process for them. So we want to isolate the DNA of the strawberry from the rest of its contents, and we have already done the exploring and research for this experiment. So we're going to move on to the supplies, prepping, trying it out, and improving. The supplies that you should have already is 2 or more strawberries, a plastic bag, 2 plastic cups, 2 teaspoons of liquid dish soap, a teaspoon of salt, a ½ cup of water, ½ cup of cold refrigerated isopropyl rubbing alcohol, a skewer or a toothpick. Food coloring is optional. I'm not really sure how it would affect it right yet because I haven't done my experiment, but I'm probably going to do that later tonight. Other liquid dish soaps, other fruits, and a teaspoon measuring instrument or a cup measuring instrument. So the other fruits are for later improvement, so you won't need them right now. Now we're going to move on to our prep. If you have all of those things, that's great. Ruby?
Yep. I ended her sharing. Everyone just make sure that she is big on your screen really quick. Put a yes in the chat so we can make sure that you can see and go along with her experiment. Okay. Cool.
And can everybody understand me just fine? There isn't any interference because there are a lot of bugs making noise out back. Okay, cicadas are very loud. So for prepping this, you're going to want to grab your strawberries. And the first thing that we're going to do is remove the greenery and leaves from our strawberries. I already removed it from 2 of them, but you just take out the leaves and the top of the little pit there, and you put that in the side or in the trash. What you're going to do then is take your strawberries and your Ziploc bag. You're going to open your Ziploc bag and just drop them in there. Got those in there? And then you want to zip it out and remove most of the air. It doesn't have to be airtight. You just don't want it to have like a big bubble of air in it. So zip it up, make sure that there isn't any little spaces for anything to get out. And what we're going to do for 2 minutes now is just mush our strawberries into a smoothie-like consistency. What you want to be careful to do is don't strangle your bag or else you might pop it. I did that the last time I tried to do that experiment and it wasn't fun. It was a little bit messy. If you do that though, you can just move the contents from this bag to another Ziploc bag, maybe add another strawberry. It's not a big deal. It just is not optimal. So I'm going to start smashing my strawberry. Another way that you can do it after you've like smushed it around a little bit in your hands is just lay it on your surface and use your palm or a fist to just mush it around there. So you're going to do this for about 2 minutes. I can't fully read the comment. I'm going to open the comments for a second. Yep, you just mush it all together. I'm going to do it on the solid surface underneath the tray. And we're going to do this for about 2 minutes. So we can either sit in awkward silence since I can't hear any of you, or I'm just going to ramble on about the strawberries.
Somebody is asking, I don't have strawberries. Is it okay if I use a banana instead for this live activity?
That would absolutely work. Right now we're doing a controlled experiment so that we all get the exact same results. Yes, it is. But you can use the banana. The results won't be too far off. But just don't expect to have the exact same consistency and look for your thing. For your banana, instead of removing greenery, you're just going to want to peel it and then take like about a third or half of the banana and stick it in your bag. I did it with bananas one of the times I tried this, one of the 5 times I did this. So that should be completely fine. So at some point it should be looking like this, and there are going to be just little pulpy parts that you can go in with your fingers and just squish them to break them up. Because they aren't going to break up from you moving your hand around, they're just going to evade it. Okay, I'm not sure how it will work frozen. It should be fine. But that'll be interesting to see how that turns out.
Maybe try using your hand as like a heating mechanism and hold them over the strawberries to melt them a bit. Maybe try doing that. But I feel like that'll be fine because like the rubbing alcohol is also cold, but that's for like the reaction part. But I feel like that'll be fine as long as you mush it up enough.
Also, if the strawberries just really aren't breaking up for you, you can run the baggie under hot water. I think I'm about done. Is everybody's like very juicy at a smoothie-like consistency? Pretty broken up. Mushed it. Yeah. All right. An astounding amount of yeses. All right. So now what we're going to make is our DNA extraction solution, or cell juice. So cell juice, cell soup. Cell soup sounds nice. So what we're going to need for this part is our teaspoons of liquid dish soap, our salt, and our ½ cup of water. So we're going to take 1 plastic cup, putting our baggie aside for now. And I am going to add our ½ cup of water first. I've measured it out already, so I have this little ½ cup measuring instrument. If you have a cup measuring instrument, just fill it up halfway with water. I'm just going to pour it in right there. There we go.
Another question, how much salt?
1 teaspoon. So I'm going to take my teaspoon measuring instrument and I'm going to do my teaspoon of salt before I do the soap. This isn't really necessary. It just makes it a little easier so you don't get salt stuck in the soap. So I'm going to fill up 1 teaspoon. And then we're just going to drop it in there, right? And then we're going to add 2 teaspoons of soap. There's 1 teaspoon. And there's another. All right. I'm going to wipe my teaspoon off with a paper towel. So quick.
Someone is saying slow down a bit, so could you explain again the measurements?
Yes, I will. I'm sorry for going so fast. All right. So what is in this cup is our DNA extraction solution. What it consists of is ½ cup of water. So you can just get your cup measuring instrument, go to your sink and fill it up halfway. And then you can come back and pour that in. And then you're going to take a teaspoon of salt and 2 teaspoons of dish soap. If anybody didn't get that, you can just tell me in chat and I'll repeat that again. Yeah, teaspoon. Remember, do not use a tablespoon, use a teaspoon. Some of you might have like these little measuring instrument spoons where they all come together. If you want to make sure you're using a teaspoon, it's much smaller than the tablespoon.
Does it matter if the soap is scented?
It shouldn't. Dish soap is probably the most effective one, but hand soap and scented soap should work just fine. So once you got that together, you're going to take your stirring instrument and you're going to stir that for about 30 seconds together. Also, if you're using a solo cup, it'll look like much less than this, but it's the same amount. I'm just using pretty small plastic cups. Okay.
Yeah, let's take a pausing moment here for everyone to stir up their solution while people get their cups if they don't have it in front of them.
Maybe mix it with a spoon or a fork, just any mixing instrument. That was originally what was on the list, but it says just a skewer or toothpick. So if you have a toothpick instead of a skewer, get like a fork or a spoon or just something to stir it with right now. All right, I'm just gonna wait for you guys to be able to get everything. Once again, if there's anything that you missed because I was going too fast, please just let me know in chat and I'll be happy to repeat it. And also in the workbook, the instructions should be there as well if you miss something later. The water should be either room temperature or cold. Because once again, the coldness helps to slow down the enzymes that want to destroy cells. And pretty much what's happening here is we're going to be adding our isopropyl alcohol later, and that is going to break open the cells and the cell walls. And the enzymes that typically will just eat away at the DNA of viruses and infections, those enzymes are going to be free to eat away at our strawberry DNA. And we don't want that to happen. So that's why everything is cold, to slow everything down.
Just to check in, raise your hand if you are not finished yet, so we can see how many people are left.
1 teaspoon of salt and 2 teaspoons of soap. I'm making sure that was the question. Yeah, that was the question. 1 teaspoon of salt and 2 teaspoons of dish soap.
Again, if anyone's not finished, raise your hand for a quick second so we can see how many of you need to still finish up. I don't see anyone raising their hand, so I think we're ready to move on to the next step.
Is raising your hand an option in a webinar?
Yeah.
Okay.
Yeah, it is.
Once again, I don't really know how webinars work completely. All right,
Yeah, so
so
nobody's raising their hand, so we're good.
it seems like everybody's got their DNA solution on hand. So now what you're going to do is you're going to take your teaspoon, you're going to take your baggie, and we're going to make what we're going to call cell soup. You're going to open up your baggie and you're going to take 2 teaspoons of this and you're going to pour it in here. Great. 1 teaspoon. 2 teaspoons. Right. And now you're going to reseal your bag once that's in there. So to get the air out, make sure that it has a nice tight seal. We can put this to the side. You might not want to pour it out just yet because, yes, 2 teaspoons. You can possibly use 3. Yes, I can repeat it. So I'm assuming that you just want me to repeat this step. So you just take your plastic baggie, open it up, and then you take 2 teaspoons of your DNA extraction solution. And you're going to put those 2 teaspoons into your baggie. And once that's done, you can seal your baggie back up, get the air out, And then you're going to remush it for about 30 seconds slowly and gently to try and avoid making any soap bubbles. But we're pretty much just mixing it together in the bag. Once again, we're just going to take 2 teaspoons of our DNA extraction solution, put it in our baggie, and then just mix it together gently.
We have someone's hand raised. What is your hand raised because you aren't ready or slowed down? I'm just checking in to see why the hand is raised, or if it was an accident or anything.
Once you're done with this step, please let me know in chat by just saying that you're done, and then we'll move on, but I don't want to move too fast.
Someone's asking, can you repeat it?
Okay, so to repeat it, you just take your baggie of your fruit mush and then take your DNA extraction, which is half a cup of water, 1 teaspoon of salt, 2 teaspoons of soap mixed up. Oh, it's okay for it to have a few bubbles. It's definitely going to have bubbles no matter what. You just don't want to agitate it like extremely and angrily, or else it will like just become a foamy consistency. You don't want a foam in your bag. You want a mush that has just a few bubbles around the top like this. All right, and then you take your 2 teaspoons of the DNA extraction solution, put it in your bag, and then you mush that up. It is really gross. It's going to smell really bad when you open the bag back up. A lot of the experiments for the chemical processes are going to smell a bit bad. Yeah.
I think it's because it's breaking down something that it makes it smell weird. Is that right?
Yeah, so I misspoke earlier when I said it was the isopropyl alcohol that was breaking it open. Right now, it's the soap that's breaking it open. My bad. That was my fault. Somebody said, can you repeat the step? I'm assuming you mean the most recent one. Again, you just open your baggie and take 2 teaspoons of this DNA extraction solution, put it in here, and then just mix it up a little bit. Just like this.
Again, raise your hand if you are not done with this step, so we can see how many people are left.
All right. So you guys will probably be able to do this later again differently as a secondary challenge. So you can keep this and don't pour it out just yet, even when we're done with it for now. So just put that to the side. We're done with it for the experiment at the moment, though. It's just so you don't have to remake it later. So it seems like everybody is ready. So what we're going to do now is you're going to grab your coffee filter. Yeah, it smells really bad. If you tend to get nauseous when you smell really certain smells, if you're just generally sensory sensitive, this might not be the best experiment for you, and you can always plug your nose or step aside or have your adult do the experiment for you if it gets really bad. But if it's just a little bit gross, then you can work through it. So you're going to take your coffee filter and you're going to put it down on a cleanable surface or a plate. And you're going to open the smelly bag. This is our cell soup. And you're going to grab your secondary plastic cup. We want to have all of these things prepared right here. And what we're going to do is pour our cell soup into the coffee filter, into the center of it. All right. And then quickly we're going to grab it at the top like this and then stick it above our cup. And now we're just going to slowly let it drain. Do not squeeze it. I repeat, do not squeeze it. Just let it drain a little bit at first. And then what you're going to do is very slowly twist it like this. And when I mean slowly, I mean genuinely so slowly. You have to be very patient for this. Every time I've done this, I've gotten impatient and my coffee filter has split open. That might happen today because I just, no matter how hard I try, I always get impatient, but you're just going to slowly drain it like this. And if it does split open, that's fine. You just need to take another coffee filter and then pour it all back into that coffee filter and restrain it. Right
Someone
now, we
said-
just want to, oh,
Someone
you
said
say
do we
something?
need a new cup for this?
yes, this is a new cup. Do not use, you can use 2 coffee filters or just 1 coffee filter. But yeah, do not do this into the cup that we made our solution. This is the second plastic cup that we put in the instructions. I repeat, do not put it into the DNA extraction solution. All right. This is going to take a little bit if you got like all the strawberries, because the coffee filters are very delicate. We don't want to just squeeze it or else it'll split open, like I said. So we're just going to sit in silence as we all gently twist our strawberry sacks into our cup to make a little strawberry liquid. This is not the DNA yet. So what this is right now is this is a mix of DNA and other strawberry contents, like a bunch of the proteins and the RNA, and what we're going to get the DNA from is this solution. It'll be just so much easier without a bunch of the strawberry guts, which are in this sack. So it split, but it didn't pour in yet. So I think that this is about good enough for now. You can do more if you want, but this is about as good as I think I'm going to get. See, there's the strawberry just squeezing out the top. All right, so I'm just going to set that on the side and throw it out later. I'm going to wait for all of you to like get to this point. Put done in the chat if you're ready for us to do the actual experiment.
And if you're not done, raise your hand and then lower it when you are done. And
Yeah.
like put it in the chat and stuff, so that when all the hands are down, then we'll move on to the next step.
This is what it should look like. The person with the bananas, yours is going to look very much like a dark yellow, almost brownish. But everybody else's should look like this sort of pinkish juice type thing. It is not a good juice. Do not drink it. Under any circumstances, do not eat anything from any of these labs. Also, Ruby, I can't see who has hands up and who doesn't. So can you let me know when all the hands are down?
We currently have 5 hands up. It
Right.
was 6, but they just, oh, now we're at 6 again. But I'll let you know. Oh, 7, 6. I'll let you know. 7. 6. I'll let you know. 7 when it's 6 when it's empty.
I feel like somebody's doing this just to spite us now.
Yeah. What do we do when the strawberries in the coffee filter filthier? Oh, what do you do with it when you're done? I guess just put it aside and throw it away. Or...
So I just normally throw mine out. I put mine to the side just in case, but honestly, just throw it out once you have like a good amount of the liquid. You might just have it like up to here, but you might have here, you might have here. Yeah. Just once you get your strawberry liquid out, you can throw out your sack of mush. My finger keeps going over the camera because I have to do that to get to the chat and close it. I'm on my phone instead of a laptop, so it's a bit stuffed. Yes, gross smell be gone. That's further out of the camera. There we go.
Now we're down to 5 hands raised.
Right. Yeah,
4,
like I said,
3.
this takes a bit, so. Oh, yay, the kitty's cute. I can't see it, but all cats are cute. It's just a known fact.
For sure. Okay, 4 hands raised. Now it's 3.
Right, we're slowly going down. We're slowly getting there.
Slowly but surely.
Mhm.
4, 3.
Okay, you have a lot, so your thing split open, so you can throw away your current little bag of mush, and then you're going to take a secondary filter. I'm just going to do this in front of you just so you can see this. If it's split into your cup, then you're going to pour your cup into the filter and then refilter it. If it just split in general and you want to redo it, then you can just take your sack of mush and then open it and then just pour it back into the new filter. Oh, that's gross. Oh, strawberry guts are gross. All right. You said that you have a lot though, so you probably shouldn't have to do that if you didn't spill it into the cup itself. I'm just going to keep doing this until we have everybody's hands down.
Just remember to lower it when you guys are done so we know when it's finished, when we can move on.
Yeah. If you have your hand up and you finish this step, then just put your hand down. Woo! Don't knock over your cup. Yeah, knocking over the cup is probably just a me problem. I don't think anybody else should have difficulty with that. But if you're as clumsy as me, then you might want to be careful about that. Oh no. Oh, I jinxed it. Oh no.
Yeah, don't worry. If you aren't able to continue with the experiment, you can easily do it directly after camp, which will be fairly soon. So you can just redo it then if you aren't able to continue. But if you have mush left, then you can keep continuing with us.
All right. So do you want me to continue, Ruby?
Okay, we have 2 more hands raised. Are you guys very close to done? So we can move on to the next step because we're running very, very tight on time.
Also, Ruby, you know how you gave me like so many coffee filters?
Yeah.
Yeah, I only have 2 left. I've done this experiment so many times.
Yeah, I gave her an inch thick stack of coffee filters.
They were so many, and when I got it, I was like, I don't need this many coffee filters. That's silly. And now I understand. Now I understand. And I'm going to probably be doing this later tonight again because I want to see what the food coloring does to it because I actually haven't tried that yet.
Yeah, I wonder if it dyes the actual strands or if they still come out clear. That's another improvement you guys can do this evening if you put the food dye in.
Also, with the experiment, the way that I've been doing it, the DNA strands have always come out clear. But I'm wondering, since what the salt's purpose is to get the DNA to stick together. So what we're going to have when we get our strands is just a salty consistency of DNA, RNA, a few proteins that haven't escaped from the alcohol yet, and salt. That's all that's going to be very soon. But what I'm wondering is if we add more salt than usual, if that will make the strands more of a white rather than a clear, because the salt is what sticks the DNA together.
True. That could be another improvement. So we have 2 more hands raised. Are Florence and Marilyn? Okay, 1 more hand raised.
Okay.
Are you almost finished? Let's give it.
If you don't have your cold isopropyl alcohol out or rubbing alcohol out yet, just go to your fridge or freezer and get that out now. That is our next step.
Okay, cool. We'll give it a little less than a minute left, and then we'll move on to the next step since it's 11:59. But that's okay. After this, we've got a little more to go, and then we'll be finished with today's day 1 of camp.
Hey.
For the people who are finished, how have you liked camp today so far? I'm glad. Correction, I love it. I'm glad you learned a lot. Yeah, good. I'm glad you had fun participating because participation puts you on the prize wheel for later during this session. Okay, are you finished? The last hand raised, are you finished with it? Okay, no more hands raised. Let's move on to the next one.
Woo! Okay. So now we're getting into the fun part. This is the create step. The caution label does not have goggles, so I don't know if you guys need goggles, but Ruby, in the notes you put that we need goggles or safety glasses. We definitely don't, but I'll put them on. I got these from like Camp Invention like 2 years ago. That was like 6 years ago. I look fabulous. All right, so the fun part is the create step. What we're going to do is you're going to get your cold isopropyl alcohol. And yeah, these goggles are great. They're wonderful. I look so cool, don't I? All right, you're going to get your cold isopropyl alcohol and you're going to slowly pour it down the side of your cup until you have an equal amount of it as you do the pink liquid or strawberry or fruit liquid. So, that is not the side that I have open. There we go. And to do that. And that's about it. All right, thank you. Thank you. All right, and now pretty much we're just going to wait. We just wait a minute. And what you'll start to notice is that these sort of gooey strands will start to separate from the liquid and rise to the surface. It's very hard to see on the camera, but you might be able to see it in real life. Those gooey strands are your DNA. So I'm going to take my skewer, and the longer you wait, if we wait like about a minute, they'll start to collect a bit more. It doesn't happen instantaneously, but the process is starting and it's separating out. You add an equal amount of alcohol as you have of your liquid. This isn't a measuring thing. This is just a guesstimate situation.
So I've got an option here. Should we set our things aside and hear our college presentation, or do that, or finish off the experiment now and then move on to the college presentation? Because if we set it aside, will the reaction be better, or should we finish this up right now?
I think we should finish this up right now. It's about finished. It doesn't take hours. See?
Oh, whoa.
There we go. That is our DNA. So once again, this is just our gooey consistency of DNA, RNA, salt, and extra proteins that the alcohol did not get rid of. And sometimes this is actually the whitest and the best I've had yet. So most of the time it was a lot less. So I'm very happy with this. But you should see that too. You can put that to the side, and if you want to, you can take a cup and put alcohol in it and then just drop it in and you can store it. I don't know what you'll do with it, but you can do that if you want to. That is how they store DNA in the actual real world, where they create experiments using DNA from different organisms. Sometimes it's plants, sometimes it's animals, sometimes it's humans. They store the DNA in a solution of alcohol. How can you see it? What do you mean?
Well,
Like,
see
how
the
are we
DNA.
able to visibly see the DNA itself?
Maybe.
If that's what the question is, you obviously can't see like on a microscopic level the DNA. Okay, why it looks like this is because of the salt that is causing the, I'm having a brain fart moment. The salt is just causing the DNA that has popped out of its cell to stick together and to come into this gooey consistency. I'm not 100% sure why exactly it looks like this, but that is what always happens. I can look at all of the documents that I've been reading because it definitely tells you at some point. I can look at the documents that I'm reading later, and if you want to come back at 5 to 6 o'clock for the later thing, I can tell you. You can. If you want to try this, I haven't tried this. I probably could because I do have a microscope. Okay, yours didn't work. All right. So what probably happened was at some point you either did not get enough, like, were you the person that did the banana? I don't remember who was doing the banana. Yes, okay. So the reason that you might not have as much DNA as everybody else is bananas have 3 copies of DNA per cell, whereas strawberries have 8 copies of DNA per cell. So yours did work, but what you'll be getting is much less. You'll be getting like just like a little drop of it. Yours is working, it's just not nearly as much. It should just have sort of a film at the top. If there is no film, then maybe try again after with some other things. I'm going to move on, even though not everybody might be finished just yet. This was our try it out part where we saw our DNA itself. Like I said, the strawberries are going to be a lot bigger, but our improvement part is where we add food coloring to see if it clings to the DNA, the rest of the strawberry, or both. I'm going to be trying this later tonight, and I'll be able to get back to you on that at 5 to 6 o'clock. You can try substituting different soaps and detergents. That is fair. You can use different types of fruits, like how Leslie used a banana. You can use any type of fruit. Strawberry works the best because of the amount of copies of DNA that it has. But you can also do bananas, kiwis, onions, raspberries, and applesauce. We share half our DNA with bananas, so that's sort of a cool thing that Leslie did. And humans have 2 copies of DNA, so a little less DNA than a fruit, which is sort of sad because it sort of says that we're less complicated than fruits. And that is your fruit DNA extraction experiment. And you can, like I said, you can do any of the improvement parts later as an extra part of the challenge. And we're going to be moving on, and I'm going to hand this back to Ruby.
Thank you, Chasey. I thought that was pretty fun to watch. And yes, that was your best attempt. the strand was like that long. But now we're going to move on to a college presentation from Emily Lott. Emily is in her second year at the University of Pittsburgh, where she is studying chemical engineering. She also plays on the women's rugby team at Pitt, and she loves to explore the city of Pittsburgh and go on fun adventures. So let's move it over to Emily Lott so she can do her presentation.
Hi, everyone. So I don't have a formal presentation, but today I'm going to be talking a lot about why I chose chemical engineering and also what your first year in the engineering program will look like. So since I just finished my first year and I'm moving into my second year this coming fall, I haven't had a lot of experience. I haven't had a lot of experience being in the actual chemical engineering program, but I am looking forward to that this coming fall. So I chose chemical engineering for a few reasons. The first reason being that I originally wanted to go to medical school, and engineering is a great degree to get if you want to then pursue medical school. A lot of people typically just get like a bio degree or a chemistry degree and go pre-med, but engineering and engineering degree really makes you a lot more well-rounded. And I just think medical schools like to see it a lot more. You have a better foundation for med school than just getting like a basic bio or engineering degree. But I also wanted a backup plan in case I decided medical school wasn't for me. It's always good to have a backup plan. And I'm obviously very interested in the healthcare field. So pharmaceuticals was also very interesting to me. And like Jennifer had talked about, people who make pharmaceuticals and medicines are chemical engineers. So I knew that this would be a perfect degree for me to get to suit my needs. So in your first year of engineering at school, you're not necessarily going to be thrown right into one specific field of engineering. So the first year is really there to help build a foundation for you in case maybe you don't know as much about physics, or maybe you don't know as much about math or something. And also, I think there's a big sort of stigma that when you go to college, you have to know what kind of engineer you want to be, which is not true at all. Absolutely not true. I knew going in what kind of engineering I wanted to do, but I had a lot of friends who didn't know, and I had friends who thought they wanted to do one type of engineering, but then halfway through the year decided they wanted to do a different type of engineering. So your freshman year, you really take a lot of foundational classes, a lot of STEM-based classes. So for me, I took calculus, I took physics, I took chemistry, and I took intro to engineering classes where we learned how to code, and we learned about the design process, which we talked about earlier in the engineering process. And this really helps you to know what you're really interested in and to help make sure that you know like exactly what kind of engineering you want to go into. And I know a lot of people also have the problem of like, well, I want to go into this engineering and I want to go into that engineering. And you can't necessarily decide, but you can also get a major and a minor in two different types of engineering. My brother did that. He got a biomedical engineering major and a mechanical engineering minor, and I plan on doing something similar by getting a chemical engineering major and a bioengineering minor. So if you're kind of stuck on two different types, you can certainly pursue both. The other thing about college that's really cool is there's a lot of clubs that you can get involved in. So one club that I'm involved in, like Ruby said, is the rugby team. So I play on the club rugby team. But there's a lot of engineering clubs, which is a lot of fun. So today we had the fun opportunity to extract DNA from a strawberry, and you can do things like that at college. So for me, my college has two specific chemical engineering clubs. One is the Chem-E Car Club, and that is a club where you and a team of engineers build a car that is run completely off of a chemical reaction, and then you compete with other schools. And then another club that we have is the Chem-E Cube Club, where you build a 1 meter by 1 meter by 1 meter box that filters a certain amount of water, and you have to be able to use your chemical knowledge to be able to filter the water properly and be able to build it in the proper dimensions that you need to, and then you compete against other schools. And these are really good real life applications, because in the real world, you need to be able to filter water like Jennifer did for the Tampa Bay Water Company. And you need to be able to know how chemical reactions can do different things. So in college, especially your first year, you really get the opportunity to see what you're interested in, because you need to love what you do. When you grow up, you don't want to get stuck doing something that you hate. I'm also involved in the Society of Women Engineers. I think that that's really important. It helps bring us women engineers together. And I think the other thing that I really love about chemical engineering is truly all the different little aspects you can go into. So Jennifer talked about this too. There's pharmaceuticals, there's healthcare, there's petroleum, there's food processes, polymers, business, biotechnology, environmental health. And like within chemical engineering, you can do so many different things. And during college, you really have the opportunity to figure out what it is that you really want to pursue and what it is that you really want to go into. So for me, like I've really enjoyed the Chemi Car Club and the Chemi Cube Club. So maybe I want to do something that kind of goes off of that. And like I said, like I want to go into the pharmaceutical side, but maybe I'll take an internship or a research position to see if I want to do something else. And yeah, so I just think like your first year, you really get an opportunity if you're worried about like, well, I don't know what I want to do and I don't know what kind of engineering I want to go into. Like your first year, especially, but even every year that you're in college, you'll be able to try out different things, try out different classes and see what you can really get involved in and see what you really enjoy. So yeah, so I'll hand it back to Ruby.
Thank you. That was a very interesting presentation. I loved it. And I am definitely going to be joining the Society of Women Engineers when I get into college. And so we are going to shift over to explaining the challenges and then doing the Kahoot and then prize wheel. So let's bring Chasey back. So we'll Chase back so we can explain the challenges really quick. Okay. So let me spotlight Chase.
Hi, I added food coloring and everything, and then I added more salt and everything went wrong. All right. So for our challenges, you can either do the fruit DNA extraction again, but using some of those improvements that we talked about and that you can see in your workbook, or you can do one of these two experiments. And I highly recommend them. They were very fun. I only really did them like 2 to 3 times while I did the DNA one like 8 times, but they were still fun. I'm going to talk about the elephant toothpaste first. So the elephant toothpaste is super fun. You've almost definitely heard about it before. You've already identified the problem, which is that you want to create an exothermic reaction using yeast as a catalyst. And you've already had the explore and design done by other people. So you're just going to create, try it out, and improve, just like this one. The supplies you'll need are safety glasses or goggles. I know that I joked about needing the safety glasses and goggles for this one, but for the elephant toothpaste and the baking soda vinegar volcano, you really will need it. You'll also need adult supervision. You'll have to be outdoors and be aware that it is messy. You'll need one empty 16 to 18 ounce plastic bottle. I don't think I have one right on hand, but I do have a slightly empty plastic bottle. This is about the size that you'll need, just an average soda bottle. You'll need half a cup of 3% hydrogen peroxide, a big squirt of dish soap, a tablespoon of dry yeast, which is the bigger scoop. You'll need 3 tablespoons of warm water, a large tray or tub for the mess, a tablespoon measuring instrument, a cup measuring instrument, a bowl, and other size shaped containers and food coloring as optional things for improvements. To prep, you'll put on your safety glasses, pour in half a cup of hydrogen peroxide in your empty bottle, followed by your big squirt of dish soap, and then you're going to just swirl it gently. In a bowl or mixing cup, you're going to add a tablespoon of yeast and 3 tablespoons of warm water, and then stir for 30 seconds. This will be your catalyst, which also means that it will smell very bad. You're then going to create by placing the bottle on a tray or tub to catch a spillover. You can put in any food coloring as an option if you'd like. You're going to keep your head back from the opening, and you're going to pour your catalyst in. You can do this tonight before 8 o'clock, Ruby. Is that the time? You're going to do this experiment tonight as a challenge. You don't have to do it, but you can.
I would recommend doing it before 5 to 6 p.m. Eastern Standard Time, so that if you have any issues, you can come on and ask us. But after that meeting, then you'll have a little bit more time to fix your issues. And then I'm closing down on the post. Well, I'm not closing it. You can still post, but at 8 o'clock, I'm going to start grabbing everything to put onto a slideshow. So get it done by 8 p.m. Eastern Standard Time.
All right. So where were we? My mom just came home. Sorry.
I think we're on the end of create or at the beginning of try it out.
Yeah. Okay. So you're going to keep your head away from the opening of the bottle. So if your opening of your bottle is here, don't look directly over the bottle. And then you're going to pour your yeast and water mixture in your catalyst. And you're going to watch as the liquids like quickly turn into the toothpaste looking foam as it shoots up. And what's happening there is you're going to pour the catalyst in, and then the yeast is going to eat away at the hydrogen peroxide and turn into a hot gas, which gets trapped by the soap and turns into a foam. That's why we didn't want to like really agitate our strawberry mixture that had the soap in it, because we didn't want to turn it into a foam. All right, and then to try it out, with your parents' permission, you can hover your hand over the foam or to maybe touch the foam once it's like sort of slowed down and see if you can feel any heat coming off of it. That's where you find if there was an exothermic reaction. Any ways to improve it is changing the amount of hydrogen peroxide, yeast, water, or liquid dish soap to see if it changes the reaction. You can change the size and shape of your container to see if that changes how the reaction shapes. And you can create patterns in the foam to make it look more like toothpaste by dripping it down the sides. You'll see that in the video that you can optionally watch. And then for the baking soda and vinegar volcano experiment, which is another challenge, you're going to create another exothermic reaction where you need to have safety glasses or goggles, an adult, and be outside and be prepared for mess. You're going to create an exothermic explosion using the vinegar and baking soda that will react together to create carbon dioxide gas. You've already done the exploring and everything, just like all the other ones. So you're going to need your safety glasses, a cup of vinegar, a cup of water, dish soap, a 2-liter soda bottle, which is, or a water bottle, which is this size. I was wrong. You need this size for the other one, and you need the giant soda bottle for this reaction. I messed up. That's my fault. I'm so sorry.
So which one's for the elephant and which one's for the vinegar?
The elephant toothpaste needs this size of bottle, a 16 to 18 ounce bottle, which is like an average water bottle or soda bottle. And this experiment will need this size bottle because it's a lot bigger. You're also going to need 2/3 a cup of baking soda, 1/3 a cup of water, a cup measuring instrument, a bowl or mixing cup, a tray or tub to catch the mess, and food coloring as an option. To prep, you're going to put on your safety goggles, combine 1 cup of vinegar, 1 cup of water, a few drops of liquid dish soap, and then you're into your soda bottle, and then you're just going to gently swirl it around. And then you can put in any food coloring that you want as an option and create a baking soda slurry in your mixing cup or bowl using 2/3 a cup of baking soda and 1/3 a cup of water. Now, When you create, you're going to put your bottle on your tray or tub just in the center. And then this reaction is a bit quicker. You might not be able to get all of your slurry in before it comes up. So keep your head away and pour it in, and then you'll observe as the foam quickly expands out of your bottle in a higher eruption and then slowly foams out like a volcano. To try it out, you can once again put your hand near the foam and see if you can feel any heat coming off of it. You can maybe touch the side of the bottle with the back of your hand, and that's how you'll know that it was an exothermic reaction, which is a reaction that lets off heat. To improve, you can change the amounts of vinegar, water, baking soda to see what it does to the reaction and add different types of food coloring. And that's all for the challenges. And remember, you can submit them to the Facebook group and have that done by 8 o'clock, and you can come by between 5 and 6 o'clock if you need any help with it.
Okay, so thank you, Chasey, for explaining the challenges. That really helped with understanding it. So on to the Kahoot. So I was trying to figure out how to do it so I didn't have to share my screen. But in order to do the Kahoot, you guys need either to somehow use 2 different screens, like a phone for the Kahoot, or, oh yeah, and by the way, put in the chat the videos for the elephant toothpaste and the baking soda and vinegar volcano for those of you who do not, spotlight, for those of you who do not have the Facebook or aren't on the Facebook page. So those are the video links right there. But we are going to be doing the Kahoot, and a quick little explanation: either do the Kahoot on your phone or your parents' phone, or try doing it split screen where the Zoom is on one part and the Kahoot is on the other part, so that you can see it, because for some reason it only shows like red, green, yellow, blue for the answers, but it doesn't show the actual answers. So we're gonna get into that really quick. Let me get it set up. Take me a quick second. I had it pulled up, but then it was being weird right now. Okay. Yeah, okay, so everybody go on their device or the separate split tab on one side of your computer and go to kahoot.it to be ready to fill in the like the code. Yeah, kahoot.it. Okay. Okay. So here's the code. I think we are all good. So let's start this in like 30 seconds. Just make sure. Okay. So let's start this. Day 1, Intro to Engineering. Okay, what percentage of engineers in America are women? It's okay if you get this one wrong, because I don't know if I explained it enough. Yeah, it's 13%. It's a very scarce number for all of the United States. It's 13%, but it's totally fine if you didn't get this one right, because I don't think I explained it enough today. I thought I would have put more emphasis on it, but the rest of them were discussed, so we're good. We got Florence in the lead. Okay, next question. An exothermic reaction generates what? Again, it's okay if you get these wrong. Yeah, the answer is heat. An exothermic reaction generates heat. And an exothermic reaction is happening in the elephant toothpaste and the baking soda and vinegar volcano because it's creating heat when the reaction happens. Oh, some people are rising up. Okay, let me, a sec. Uh-oh, what just happened? Oh, okay, we're good. We're good. But how do I get to the next question? I'm very confused. Okay, there it is. Sorry about that. Okay. Chemical engineers design solutions for blank. They design solutions for all of the above because, like Jennifer said, they do pharmaceuticals, which is medicine. They can also do paper and they do water treatment, but it's all of the above. It's kind of a trick question because it's all of them. But yeah, so technically all of you were right. Some more people are rising up, but Florence is in the lead. Okay. Chemical engineers use their specialized knowledge of blank to develop solutions. This was on your fill in the blank thing. Oh, the game pin. Let me put that in the chat. See, maybe you can join late. Yes, it's chemistry because chemical engineers use chemistry. Okay, on to the next one. Florence still in the lead. Okay, blank are needed to boost the chemical reactions. Remember, this was talked about within one of the challenges that she just went over, that Chase just went over. Yes, catalyst is used. It's used to speed up the reaction. Florence still in the lead. Okay, next one. Which of these do not belong? Yes, engines does not belong because there's processes and reactions and chemicals in chemical engineering, like we had on the fill in the blank page. Florence still in the lead. She's up there. Okay, chemical engineers are blank. This is just a cute little one. I think you'd know the answer to this one really easily. Yes, all of the above. Chemical engineers are creative, they're inventors, and they're problem solvers. Okay. Which is not one of the core 4 engineerings. Remember, one of these are the ones that branch off of another one. So it's not a core 4, one of these. Yes, aerospace. Aerospace branches off of mechanical engineering. And last one, what do I want to be when I grow up? Yes, chemical engineering. I'd love to be a chemical engineer when I grow up. I've wanted to be one since I was like 3. Okay, here's the podium. Hey, with a winner of, oh, runner-ups. Okay, so there was that. So next we are over to the, one second. Okay, so next we are going to be doing the live poll. Okay, so we just went over chemical engineering, so now we're going to do a poll about it. So everyone fill out this poll really quickly. Now, how much do you know about chemical engineering? Oh, a lot of you are saying a lot. I'm glad you guys know a lot about it. I was really hoping that this would give you a lot of information about it. So 24 have answered, I think. Okay. So here are the results. Majority of you know a lot, so I'm very glad that you do. I was hoping that this would be a little bit of a learning moment, but also a very fun day of camp. I'm glad that day one went pretty smoothly. I was hoping for that, and I did pretty good. We all did pretty good. I'm glad you love this, Hayden. So thank you all for coming to day one of camp. I thought it was pretty good, pretty smooth, pretty good. But thank you all for coming, and thank you to Emily, Jennifer, Caroline, and Chasey for she might have already left. No, she's still here. So thank you to everyone, all of you guys, and all the people who have presented, helped with the activities, done the prize wheel. Thank you all for coming, and thank you for helping me with my project. I hope to see you guys tomorrow, and thank you, Jennifer, Emily, Caroline, and Chase. So I hope you guys have a good day, and I'll see you guys.
Bye.